Hello dear students, welcome to the new video of Co-ordination compound chapter. In this video, we are going to study how to write name from formula. Like you'll be given a formula and you'll be asked to write the name of the compound. Now, in order to write the name, again you have to follow some rules. So rule number 1, in case if the compound is ionic, you'll write the name of the cation first, followed by an ion. Next rule is for writing coordination entity. So when you're writing the coordination entity, you have to write the names of the ligands in alphabetical order. So while writing the name, you'll have to first write the name of the ligands followed by central metal atom or ion. It's just opposite of writing the formula. In case of formula, you first have to write the central metal ion followed by ligands in alphabetical order. But in case of name, you'll first write the ligands in alphabetical order followed by the central metal ion. Next rule, you have to calculate the oxidation number of the central metal ion. And the oxidation number is written using Roman numerals. Next, in case of ionic complexes, if it is cationic, there will be no change in the name of the central metal atom or ion. Like cobalt, nickel, platinum, zinc, chromium is written for neutral or cationic. But in case of anionic, platinum will become platinate, nickel will become nickelate, chromium, chromate, iron will become ferrite, titanium will become titaniumate. So for anionic complex, you'll add ATE to the name of the central metal ion. So let us take some examples. Example number 1, CO, Cl4, all 2 negative. So we are going to write the name of this compound. And this compound is an anionic compound without a counter ion. So straight away we'll start with the coordination entity. So while writing the coordination entity according to the rule, you'll first write the ligands in alphabetical order. Now here you have only one type of ligand, so no need to follow any alphabetical order. So we have Cl, name of Cl is chloro, or you can write chlorido. 4, we'll use the prefix that is tetra. Co is cobalt, but since it's anionic in nature, it will become cobaltate. So we start with the ligand, that is tetrachloro. Tetrachloro. Tetra means 4, chloro is Cl. So we have tetrachloro. Next, we write the name of the central metal ion, that is cobaltate. After that, you have to calculate the oxidation number of the central metal ion. So you know the formula, you know how to calculate the oxidation number of central metal ion. Let it be X plus Cl, charge is -1 multiplied by 4 is equal to charge of the complex, that is -2. So if you solve, you'll get X equal to +2. So we'll write the oxidation number using Roman numeral. After this, since is charge, since anionic, will 8 ion. So the name of this compound, that is COCl4 whole 2 negative, is tetrachlorocobaltate 2 ion. Let us take the second example. Now here, in this compound, we don't have counter ion, so straight away we'll start with the coordination entity. Br, bromo or bromido. Cl is chloro or chlorido. Instead of writing chloro, you can also use the name chlorido. NH3 is amine. So first you have to write the names of the ligands in alphabetical order. So if you check alphabetically, bromo starts with B, chloro starts with C, amine starts with A. So if you go in alphabetical order, A will come first. So we'll start with amine. Now how many amine do you have here? 2. So we'll use the prefix di. So it's diamine. Next, you have bromo, chloro. Now if you check alphabetically, B will come before C. So next will be bromo. You have 2 bromo, so it will be di-bromo. Followed by di-chloro. So we are done with the ligands. Next, central metal ion. The central metal ion is Cr, that is chromium. But since the complex is negatively charged, that is Ionic complex, chromium will become chromate. So we'll write CHROMATE, chromate. Next, we'll calculate the oxidation number of the central metal ion. So let the oxidation number of chromate be X plus Br is -1 multiplied by 2, since you have 2 Br, plus -1 multiplied by 2, plus NH3 is neutral ligand, so charge carried by neutral ligand is 0, multiplied by 2 is equal to charge of the complex, that is -1. So if you solve this, you'll get x minus 4 equal to -1, which implies x equal to +3. So the oxidation number of chromate in this complex is +3. So we'll write 1, 2, 3. Ion. So this is the name of the given compound. K3 FeCN whole 6. Now here, this compound contains counter ion, and the counter ion is K, and it is positively charged. Now, since the counter ion is positively charged, the coordination entity will be negatively charged. So you have to be very careful with the compound which contains counter ion. Remember, if the counter ion is positive, coordination entity will be negative. If the counter ion is negative, coordination entity will be positive. So you have to be very careful here. So potassium positively charged, coordination entity is negatively charged. Now since the counter ion is positively charged, we'll start with the counter ion, that is potassium. Now here you can see K3. That means you have 3 potassium. But while writing the name of the counter ion, you don't have to write the number. That means you don't have to mention the number of counter ion. You'll just write the name. That means if you have K3, potassium, even if it is K2, potassium, even if it is K4, potassium. So you'll not mention the number, you'll just write the name. So we'll start with potassium. Next, we'll write the coordination entity. Again, for coordination entity, the rule is you have to start with the ligand in alphabetical order, followed by central metal ion. So since you have only one ligand, there is no need to follow alphabetical order. So it's cyano. You have 6 cyano, that means hexacyano. Next. Counter ion is positive, coordination entity is negative. So Fe, instead of iron, will use the name ferrite. Now why ferrite? Because for anionic complex, iron is written as ferrite. That is Ferrate, ferrite. After that, you calculate the oxidation number. Now, K3. K3, each potassium will have 1 positive. So 3 potassium will carry 3 positive. So the charge on the coordination entity will be 3 negative. Remember, if the total charge of the counter ion is 3 positive, charge on coordination entity will be 3 negative. If the total charge of the counter ion is 2 negative, charge on the coordination entity will be 2 positive. So the charge on the coordination entity here is 3 negative. So let the oxidation number of iron, that is ferrite here, let it be X plus Cn carries -1 charge. You have 6 Cn, so -1 multiplied by 6 is equal to -3. So if you solve this, you'll get X equal to +3. So the oxidation number of ferrite in this complex is +3. So 1, 2, 3. Now, since you have a counter ion here, you don't have to write ion in the name. Now, in this compound, the counter ion is negatively charged. Keep this in mind. If the counter ion is on left hand side, the counter ion is positively charged. If the counter ion is on right hand side, the counter ion is negatively charged. Cl will act as counter ion. That means we'll use the anionic name. And what is the anionic name of Cl? It's chloride. Chloride. Now, the counter ion is negative, coordination entity is positive. So we always start with the cationic part. That means here we'll start with the coordination entity. So again, for coordination entity, the rule is ligand followed by central metal ion. So we'll write the names of the ligand first. H2O, name is aqua. NH3 is amine. Now you can see here, aqua starts with A. Amine also starts with A. Now if you compare the first letter, it's difficult to find out the order of the ligand. So what do? We take Q, A, Q, A, M. So if you compare Q and M, and according to that, we'll write the order. So if you compare, M will come before, amine will come before aqua, so we'll write tri-amine, tri-aqua. The metal here is CO, that is cobalt. Now since the counter ion is negatively charged, the coordination entity will be positively charged. So for this, we don't need to add ATE to the name of the central metal ion. So we'll just write it as cobalt, C-O-B-A-L-T, cobalt. After that, you calculate the oxidation number. Now, the total charge of the counter ion here is -3. Because each chloride ion will carry 1 negative charge, so 3 chloride ion will carry 3 negative charge. That means the coordination entity will carry 3 positive charge. So let the oxidation number of cobalt be X. H2O is the neutral ligand, 0 multiplied by 3. Again NH3 is neutral ligand, 0 multiplied by 3 is equal to the charge of the complex, that is +3. So if you solve this, you will get X equal to +3. So we'll write here cobalt 3. Next we have to write the name of the counter ion, that is chloride. Now since chloride is negatively charged, that is anionic, it will be written after the coordination entity. That means on the right hand side. It is written as chloride. So as I have already we have already discussed, we don't need to mention the number of counter ion. You just have to write the name, irrespective of the number of Cl. If it is 3, 4, 5, you don't have to mention the number. You just write the name. That is chloride. If it is Br here, it will be bromide. So this compound is without counter ion. So we straightway start with the coordination entity. Ligands first. So you have H2O as ligand. The name of H2O is aqua. You have 6 aqua. That means we'll use the prefix hexa. So hexa, aqua, Ti is titanium. Since it's a cationic complex, you don't have to add ATE. So we'll just write titanium. After that, calculate the oxidation number. X plus 0 multiplied by 6 equal to +2. So oxidation number of titanium here is 2. And since it's 2 positive, we'll write ion. So that's all for today, for this video. In the next video, we'll study isomerism. We'll study different types of isomerism shown by coordination compound. Thank you.